Welcome everyone to Knox Game Design for February 2024. My name is Levi Smith. So this month I'm going to be talking about texture mapping. I'm not going to go into a lot of the mathematical details. There's a lot of documentation out there. I'm going to focus more on basically how to texture map polygons and how to pull that into various game development environments. So basically, texture mapping is a method for applying a 2D image to a 3D polygon. I'm going to go over how to create a texture image, how to apply that texture to polygons in OpenGL, how to actually texture map something in Blender, then how to import a texture mapped FBX model into Unity, as well as displaying the texture map model in MonoGame. And I'm also going to look at MonoGame and Unreal Engine as well. So first of all, how do we create a texture image? Well, the program I like to use is GIMP Image Editor. It's a free open source program that anybody can download for many different platforms. When you're texture mapping, I think it's a requirement that it has to be power of 2. So typically we have texture map images of size like 1024 by 1024 or 512 by 512. And in this example, I'm going to be using a 512 by 512 image. And what we're going to do is export this image into the BMP image format. It's an old format. It's easily parsable. So if we go back and open up GIMP. So this is our image right here. I pulled this in, and basically it's 512 by 512. It's pretty easy to create an image in GIMP. You just go to File, New, and you can do like 1024 by 1024 for the dimensions, and OK. Then you can use the drawing tools or import your own image into here and scale it or whatever as needed. But what we're going to do is we're going to do File and then Export. And then for our image, we're going to give it a name and then hit Export. And one thing you got to make sure is you got to click Advanced Options and make sure you got this R8, G8, B8 selected before you export. Otherwise, you'll run into issues for this example that we're doing. So the one thing about OpenGL, it doesn't provide like any native methods for reading image files. So what we've got to do is either write our own image reading code or use a library. So we'll look at how to actually read a BMP ourselves. It's not too difficult. But one thing when you're using OpenGL, you got to make sure that you use the command GL enable with the parameter GL underscore texture underscore 2D first. Otherwise, all your polygons are going to look white. That's one issue I always run into when I get started with OpenGL. I get a bunch of white polygons. Like, oh, why isn't the texture showing? Well, you can have all the right calls for your texture mapping, but if you don't GL enable GL texture 2D first, then you won't see anything. So as I mentioned with the image format, make sure you select R8, G8, B8. If you like select the A8, R8, G8, B8, or the R5, G, whatever, then you're either going to get an image that looks like this where it's really scrambled, or you're going to get a segmentation fault. So make sure you're using the right format. So this is some example code right here for actually reading in the pixel data from from a BMP file. One thing you got to watch out for is where your pixel data actually starts, and that's defined in the header of the BMP file. And actually, the data position is at hexadecimal location 0A. So you can use this command right here to get the location where the pixel data starts. And also, if you want to get the width and height, that's at hexadecimal locations 12 and 16. And also, the image size is defined at hexadecimal location 22. So down here, what we're going to do is we got this data right here. And data is just basically a pointer to a character. Basically, a pointer to character data right here Then we're going to do malloc, memory allocate, then the image size, the pixel data we want to hold. Then we're going to use fread, pass in the pointer to the data one, image size, and the pointer to the file handler. So we define the file handler up here, file, star file, fopen, file name, RB. Then we close the file right there. So all BMP files start with the characters B and M. One thing that I should do is like some additional error checking. I don't have that in here, but you can check for things like that BM being at the start of the file. And what we're going to end up doing is using fseek, which is a C command, to move to the starting location of your pixel data, which is in that data position variable. Then we're going to use seek underscore set parameter to start from the beginning of the file. And yeah, once we got all that read in, the pixels are read as BGR bytes, which is a little bit unintuitive. Typically, we're familiar with RGB, but it's a little bit backwards. So we got to take that into consideration. So if you just start reading the pixel data at the beginning of the file, you're going to get an image like this first one that doesn't look right, with it looks like it's shifted over. And the reason that is because it's actually reading that header in as pixel data in the lower right corner right there. So that first so many bytes is being read from the header instead of the pixel data. So if you don't seek to the correct pixel data location, then you'll get this effect. If you do seek to the correct position, then you'll get the correct borders like this. So I ran into this problem when I was doing these demos. I was like, what's going on here? Then you realize, hey, I'm reading the pixel data and it's part of I'm reading the header in as part of the pixel data. Other thing you got to watch out for is don't use a constant for the starting pixel data size. Like first thing I started out, I looked online, I was like, oh, the pixel data starts at like location 49 or 52. And well, that may be true for some cases, but not always. So you want to get it out of that header location for the starting pixel location. So here's some OpenGL commands and structures you wouldn't want to have. So we got GLU int, GL unsigned int, which is a texture with the texture ID. So that's going to point to our OpenGL texture. Then we're going to texture map. We got commands GL gen textures, passing 1, and the address of our texture ID that we'd have in our GLU int. We're going to call GL bind texture, GL underscore texture under 2D, and pass in the texture ID. Then GL text image 2D with GL texture 2D, 0, GL RGB, the width and height of our image, 0, GL RGB, then GL unsigned byte, then pointer to our data, pixel data right there. Well, one problem is like we're using RGB right here, but our data is going to be in BGR. So that command generates our texture. There's also some additional commands you can use, like GL text parameter I. You can use that to do things like setting mip map options. I'm not really going to go into depth about mip mapping, but basically it generates smaller texture mapped images in memory for you. So if an image is a polygon's real far away, or if it's small, then it doesn't use that full high resolution image for doing the texture mapping. So this is basically how we texture map a just one quad, 4-corner square right here. So we're going to use GL text coord, CORD 2F, to assign texture mapped UV coordinates before each call to GL vertex 3F. So GL vertex 3F is like the world positions of our polygon. And basically UV, that's our X and Y coordinate of our texture image. So if you hear UV mapping, that's basically XY for our texture map. So basically we're going to call like 0, 0, 0, 0 for our texture. Then we're going to send that to the vertex at -2, 2. And then we're just going to go to each corner of that texture mapped image, 0, 0, then 1, 0, then 1, 1, then 0, 1. And assign those to the vertexes vertices in the 3D location. I'm going to go back out. Let's look at our image here, OpenGL 01. So this is basically just our one quad right here. Nothing fancy going on right there. If we look at our texture map, OpenGL01.c. So I did a talk last month about OpenGL. May want to give that a watch. I'll go into detail about basically how to set up the V volume and the camera, like glue lookup, glue viewport, glue perspective, all that good stuff. The only thing that I'm adding here is like at the beginning, that function to load our RGB data from the file, which I mentioned earlier. That's going to return that pointer to character data. And then basically I'm going to use those OpenGL calls to set up the texturing. And then here's our quad right here after GL begin GL quads. And that's what generates that image right there. So in the second example, OpenGL 02, we're going to add in the additional faces. So I'm just doing top, front, and left. So that's going to be like part of a box and texture mapping each of those corners using GL Text Chord 2F and GL Vertex 3F right there. So if we run OpenGL 02, then that gives us our 3D box right there. But as you'll notice, it's blue when we're expecting red. So that's the problem with the byte order right there. I'll go back to our slide right here. So I think in an older version of OpenGL, they actually had a GLBGR byte order, but that apparently no longer works, which is unfortunate because our BMP data is in blue, green, red byte order. But we need to swap every first and third byte to correct the color. So basically, I just have a loop starting at I = 0 for the start of the pixel data. And then I have variables for R, G. Well, I have the G commented out and B. So the R byte is going to be I + 2, and the B byte is going to be I + 0. And then down here, we're just going to swap those 2 bytes, and then we're going to increment I by 3. So we're going to do every 3 bytes. So if we go back, for example, so if we look at texture map OpenGL03.c, then here in our data load code, file loading code, this is where we're swapping our red and blue bytes right there. So if we go and run texture map OpenGL03, then we get the correct color now. Some additional options in OpenGL. There's texture wrapping. So if a texture doesn't fully fill a polygon, how is the rest of the polygon going to be filled? So there's some options: GL texture wrap S and GL texture wrap T. So that's for clamping the U and V positions, or X and Y, of your texture map. Some of the options you can supply or GL clamp to edge, GL clamp to border, GL repeat, you want the image to repeat, or GL mirrored repeat, you want it to mirror, or GL clamp to edge. Okay, so that's kind of like the hard way, hard path for texture mapping an image. But in most cases, if you're developing a game, you want to use a tool. I like to use Blender. It's free and open source. So here's an example of a texture mapped image in Blender. Just going to start out with a cube and unwrap it, and we get kind of like this unwrapped box, kind of like a cross, and that isn't really how we want it texture mapped, but I can show an image, the demo of that. So this is it completely texture map. Here's kind of like our end result right here. You can see over here, here's our texture image right here with it mapped out. But if we go File, New, General, let's not save that. So right here, we can like go into UV editing. That gives us that unwrapped box right there. But what we want to do is we do image open, and then we go get our texture file like right there, and we open that right there. So that's not going to look right. We can go over here to materials, and you can go to base color and use an image texture, and then open, and then go get our PNG file or our BMP file, open that, and then press Z right here, material preview. So yeah, that doesn't look right at all. It looks okay, but not quite what I was really expecting. So how we fix this is my quick and dirty way of texture mapping. So you want to select faces, do Alt A right there, and do B, and that should give you the top. Let's go to wireframe. Press 7, Alt A, B, and that'll give us the top and bottom. So what we can do is do UV project from view bounds. So now if we go back to material, so the top looks right and the bottom looks right there, but the sides are still messed up. So we want to do 3 on our keypad, go back to wireframe, Alt A, B, and we're going to do UV project from view bounds. And while we're doing it, let's do a 1 number keypad, Alt A, B, select that, do UV project from view bound. So that's going to make it fill up the whole entire thing. So now all of the faces should be texture mapped. So if we do Z and go into material preview, now it's texture mapped correctly. And probably if we do an F12, then there's our texture map box right there. So that's a quick and dirty texture map right there. So basically what we want to do, let's go back to the slides. So yeah, cube projection. So if you really want to do this correctly, you want to define seams. If you have a complex mesh or model, you want to define seams along edges, then you can do different types of unwrapping. Like I did the project from view. Just then, you can do cylinder projection for cylinder type objects, sphere projections, or you can do the face select and limit unwrapping to selected portions. I like to do that a lot of times. And basically, I showed how to texture that material. Press the dot next to base color, select the image texture, then open, select your flag file or your image file. It would be a PNG or a BMP. Then in edit mode, press Z to go material preview. So to export to FBX is pretty easy. Like I just did that in render with F12, export to FBX if you want to use it in Unity or other game development environments, and do file, save as, save it as just a Blender native file, and do file export to FBX. Select mesh only, or you'll get the camera and the lighting, which you don't want. So you just do file, export to FBX. Then you can, here's where you select the object type. So you only want the mesh right there. And then you can export that out to whatever directory you want to do. Another thing, you always want to come up here and always rename it something other than cube, like mesh Tennessee box or something. It's just good to get in that habit, because when you import these things into game development environments, you're not going to know what the heck a cube is, if it's an enemy or a player or a weapon or whatever. So it's good to go ahead and get in the habit of like renaming that. So importing into Unity is pretty easy. Once you have that FBX file exported, you just drag it in. And you still have to drag in the texture separately, your image file, but it usually like automatically applies it once you pull it in. So we can look at that. We got Unity right here. So here it is already pulled in right there. Yeah, it's pretty simple. Go ahead and delete this. But basically what I usually do is I just go to my file explorer and then find the file. I got it in my directory here. Then texture map, Blender. So you always want to get the FBX file. So I go into models and delete this. And also the textures. Go ahead and delete the texture as well. We can go to models, go to our file, and then just drag in the FBX right there. So if you drag it in and it doesn't have any textures right there, what you want to do is go down to textures and then grab your PNG or BMP, whatever you use. And then it automatically textures it. So then you just drag it into your scene right there. So it's pretty simple. And you can go to, just move to 0, 0, 0. And we got our camera right there. Press play. And there it is right there. So yeah, that could be like an object in your game, a card, a player, an enemy, whatever. But that's just basically how to get a texture mapped image into your Unity game right there. So make sure that's stopped right there. Okay. And that's basically what I'm showing on this slide here. Our texture mapped image right there. So if we wanted to use MonoGame or XNA, previously XNA, a little bit more difficult, but not too bad. Basically, you want to set up some variables here. Vector 3 for camera target, vector 3 for your camera position, a matrix for you got to have 3 matrices, one for projection matrix, one for view matrix, and one for world matrix. Then a model object for our model. We want to go into the MGCB editor and add the FBX and PNG files as content, and then save that out. In our initialize, we're going to set our cam target and cam position to world coordinates right here in vectors 3s. Then our projection matrix, basically I use these settings. So we're going to pass in like the field of view, reference to the graphics device viewport, aspect ratio, the near clipping pane, the far clipping pane, a view matrix. I'm going to use matrix create look at, camera position, camera target, and the up vector right there. And then a world matrix, which is camera position, camera target position, vector 3 forward, vector 3 up. Then to load the FBX file, we're going to use model gets content.load and angle brackets model. Then we're just going to pass in the name of that FBX without the .fbx extension. So that's Tennessee box. Then in our draw method, we're going to go for each model mesh and model.meshes. We're going to go for each basic effect and mesh.effects. Then that's where we're going to actually do effect, set the ambient light color, the view to the view matrix, the world to the world matrix, and projection to projection matrix. Then after we do that, we're going to call mesh.draw. That's going to draw it to the screen. So that's basically what it did right there. So let's go look in Visual Studio. I already have the MonoGame project set up right here. This is where we define our matrices and our vectors and our model object. Here's our initialize, our camera target, position, projection matrix, view matrix, world matrix, and our model right here. And then here's our draw code right here. So this is where we're looping through all the meshes and all the effects, setting the ambient color and the view in the world, and then mesh.draw. So if we press play, it's going to start up, and there's our box right there. So it really doesn't do much, but it does prove that we can pull that texture mapped image into MonoGame. And by the way, our content MGCB, double click that right there. And you can see here's our Tennessee box FBX and our Tennessee flag.png. So you got to make sure to do that, or else you won't, it won't be imported. So the next environment we're going to look at is Godot engine. So I did some reading into Godot, and by default it doesn't import FBXs. They say, oh, it's a proprietary format. So it supports GLTF by default. Blender can export to GLTF just like an FBX. So it's just a different format to export to. You want to copy your .glb file for GLTF to the Godot project directory. It should automatically display under the file system tab. You want to drag your .glb entry under res:// into the scene. Node for the texture mapped object should be automatically created under the root node in your scene tab. And yeah, by default it doesn't create a camera for you, so be sure to add a camera 3D node under the root node, or else you won't see anything. And this is what it looks like in Godot engine right here. I actually have it pulled up right here. So here's our world with our box pulled in. We can press play, and there's our box right there in Godot engine. And as I mentioned, here it is under our file system res. So you just drag in your GLB file that you exported from Blender and drag in your PNG file. And I think I should be able to click on this and delete our Tennessee box right there. You should just be able to drag that GLB file right there. And you can use like the little handles to rotate it or whatever you want to do. Rotate it on its side or scale it to make it big or move the position. Yeah. So if you're developing a real game, you'd add logic and stuff to all this to make it do stuff. Unreal Engine. So I'll try to add video of Unreal Engine. I don't have it on this system right here, but it's pretty easy. Unreal Engine, you can import an FBX. Just go to your content browser. It should be in the lower left-hand corner, and select add import, then import to /game. You only need to select the FBX file. The PNG texture should be imported automatically. There is an option in Blender to like pack in the image that may be required. I'm not positive. But your material should be generated automatically. Then you drag the generated static mesh into the scene. And then when you import this, you're going to get these FBX options over here. So I just used the default and just click import. It seemed to do okay. Didn't have any problems just using the default. But there are a lot of options when you import into Unreal Engine. And this is what it looks like right here when you import into Unreal Engine. Right there into the world scene, just like the Unity and Godot. Yeah, so here's an example of how to import a FBX texture mapped model into Unreal Engine. So you see you just need to select the FBX file, press import, and then it automatically gets the texture for you. Then you drag from your content browser into the scene and line your object up, and you can press play, and then you're good to go. You can use the built-in editor controls to move around and see your your 3D texture map box. So yeah, that's basically Unreal a texture map box in Unreal Engine using FBX export. Yeah, so that's basically an overview of how to import, how to create a texture mapped image, how to create a texture mapped object using the old school OpenGL, and also how to generate a texture mapped object in Blender and then export that into either like an FBX or GLTF to import into one of many different game development environments: Godot, Unreal Engine, Unity, or MonoGame. I couldn't think of any others, but that's quite a few options for texture mapping there. So hopefully everyone out there found it informational, hopefully found it useful. So that's going to wrap it up for Knox Game Design for February 2024. Hope everyone enjoys their extra day of February this year, the 29th, and I'll plan on being back in a month.